M&M Quiz 2040 Change of Speed and Distance. Initially, Miss Duda is driving at an unknown speed, high speed. After Miss Duda notices a police car, she drops her final speed to the speed limit of 20 meters per second within 4 seconds. What was the displacement during this change of speed? Assume constant acceleration against the direction of motion at the rate of 8 meters per second per second. A, is it 9 meters? B, is it 144 meters? Or is it C, 80 meters? Positive x is defined as to the right. We do not know the initial velocity. We know the final velocity. And we want to know the displacement. When you look at the equation for the displacement, you know that the displacement is equal to average velocity times time. To get the average velocity, we need the final velocity, we need the initial velocity, and then final velocity plus initial velocity divided by 2. This is your average velocity times time. We know the time. We know the time. We know the final velocity. Final velocity is 20. Final velocity is 20. Initial velocity we don't know. We know the time and 4 seconds. So how can we get the initial velocity? So for that, we are given acceleration. What is the acceleration? It is against the direction of motion, so it is negative 8 meters per second per second. The change of velocity is negative 8. So from an initial high speed, after 1 second, it will be 8 less. So let's find the initial velocity by acceleration. Acceleration is change of velocity divided by time. Acceleration is v final minus v initial divided by delta t is, let's assume that we started at t is equal to 0, t minus 0. So it is t minus 0. So what is the acceleration? V final minus v initial divided by time. So what is acceleration times time? And that will be equal to change of velocity, which is v final minus v initial. From that, we get v initial is equal to v final minus acceleration times time. Minus acceleration times time. So substitute the numbers that we know. So v initial is equal to v final. V final is 20 minus, what is the acceleration? Negative 8. And what is the time? Time is 4 seconds. So this is 20 minus negative 32. So this is 20 plus 32, because negative of negative is positive. So it is 52 meters per second. What is the unit? Meters per second. What is the magnitude? 52. And what is the direction? Along positive x. Now we have the initial velocity, the final velocity, and the time, so we can find the displacement. So displacement is equal to, what is the final velocity? Final velocity is 20. Remember, she brought it down to 20. What is the initial velocity? We just found that out. 52 divided by 2. And that's your average velocity times time. What is the time? 4 seconds. So what do we get? 144 meters. Why? 20 plus 52 is 72. 72 divided by 2 is 36. 36 times 4 is 144 meters. What is the magnitude? 144. What is the unit? Meters. And what is the direction? Along positive x. We do not know the initial velocity. Final velocity is 20. Time is 4 seconds. Acceleration is negative 8. Acceleration by definition is final velocity minus initial velocity divided by time. Cross multiply. Acceleration times time is equal to change of velocity. Solve for v initial. V final minus at. Substitute V final, substitute A, substitute T. A is equal to -8, T is equal to 4, and V final is positive 20. When you substitute all that, we get V initial is 52 meters per second. So that's what I have here, 52 meters per second. What is the unit? Meters per second. What is the direction? Positive x. And what is the magnitude? 52. Once we have V final, V initial, then we have the average velocity. Once you have the average velocity of 36 meters per second and a time of 4 seconds, average velocity times time gives you the displacement, and that is 144. What is the magnitude? 144. What is the direction? To the right along positive x. What is the unit? Meters. Or we can go for delta x is equal to v0 t plus 1/2 acceleration times time squared. This is all along the horizontal, okay? Please don't forget, what is the initial velocity? Initial velocity is 52. We already know that now. What is the time? 4. So we have that plus 1/2. Now here is where we make a mistake. What is the acceleration? It is against the direction of motion. It is not, you're not increasing your speed, you're decreasing your speed. So what is the acceleration? -8. And what is the time? It is 4 squared. So what is 52 times 4? 208. And what is 1/2 of -8? -4. And what is -4 times 4 to the power of 2? -64. So what is 208 minus 64? It is 144. What is the unit? Meters. What is the sign? Positive. So what is the magnitude? 144. What is the direction? Along positive x. And what is the unit? Meters. Or we could have gone for V final squared is equal to V initial squared plus 2 times acceleration times displacement. Immediately you see that displacement is equal to V final squared minus V initial squared divided by 2 times acceleration. Substitute the numbers that we know. V final, don't forget, final velocity is 20. Initial velocity is 52. Divided by 2 times, what is the acceleration? -8. Please don't forget that. -8, negative, negative, negative. It is against the direction of motion. So, what is that number? 144. 144. What is the magnitude? 144. What is the direction? Positive x. And what is the unit? Meters. This is George Mathew signing off for both myself and my dad. Good luck.